Participants kindly join quickly. We need to start. We can we can start, Sushmita.
With the warm greetings, I extend my warmest welcome to each and everyone invited here. I am Sushmita, doing my third year in the Department of Electronics and Communication Engineering at Chennai Institute of Technology. We are analog beings living in a digital world facing a quantum future. The time as a caterpillar has expired and the wings are ready. Yeah, it is about transforming lives. It is indeed a privilege for all of us to get the opportunity of attending this webinar. I now request our organizing secretary, Ms. Malati, to share few words. Please, ma'am.
Yes. Good to one and all present here. I heartily welcome to you all the Knowledge 4.0 webinar series. This is one of the trend-setting and innovative initiative of Chennai Institute of Technology. CIT established in the year of 2010. Within the short span of time, we achieved the top 10 positions among the 522 colleges affiliated to Anna University, Chennai. Knowledge 4.0 webinar series going very successful manner under the guidance of our Honorable Chairman Sri P. Sriram, the first generation entrepreneur, a well-known industrial and managing director of MK Group of Companies. We have we have been conducting various webinars under this webinar series such as technical webinar, research webinar series, innovation webinar series, and career guidance webinar series. In addition to this webinar series, we have been also conducting workshops, conferences, and seminars. Today we have AICTE sponsored 6 days online STTP Series 2, that is Phase 2, on the Internet of Medical Things Enabling Technologies in Healthcare. I welcome our expert Dr. Sudeep Roy from the IIT Roorkee for today's session. Thanks a lot for accepting our invitation, sir. Today he is going to deliver the lecture on the biochips for healthcare applications. Welcome you, sir. Regarding participants 80% of attendance is compulsory to get the certificate. Try to attend all the sessions. Feedback link and PPT will be shared at the end of the session. Regarding attendance, we will take from our webinar platform. For this, you need to attend only, log in and properly attend the session. Thank you. Sushmita.
Yeah, ma'am. Today we have our expert, Mr. Sudeep Roy, Assistant Professor in the Department of Computer Science and Engineering at IIT Roorkee. So talking about our expert's profile, he has completed his BTech in the Department of Computer Science and Engineering at University of Calcutta. Not stopping there, he has completed his MS by research in the domain of Computer Science and Engineering at IIT Kharagpur and PhD in the same domain IIT Kharagpur. He has his professional membership in IEEE and ACM. He has published many journals and took part in many conferences as well. He got awards and honors like Best Poster Award in Self Bio International Conference. His area of research are cyber physical and IoT based system design. Yes, I have already spoken for too long. So without further, I will hand over session to our expert. Will you please? Sir?
Oh, okay. Yeah, thank you, Susmita and Dr.
Malati. Malati.
Malati. Yeah, sorry. Yeah. So basically, yes, I am going to talk about something about the microfluidic biochip, which is a very interesting domain of doing research. I have been doing the research on this topic uh, since let me share the screen first. So this I think where it is
Top, sir, on the top, on
application.
top.
Yeah, on top in the share screen, I clicked, but the application is not coming. That so enter screen maybe I can share, right? So yeah, that is better. Application was not coming. Yeah. So is it visible now?
Yes, sir. Make
Is
it.
it visible
Yes,
now?
yes,
Yeah.
yes, sir. You can proceed.
Yeah. Yeah. So good morning, everyone. So basically, I am Sudeep Roy from Indian Institute of Technology, Roorkee. And today's topic that I want to discuss in next maybe maximum 1 hour. It's on basically microfluidic biochips for healthcare applications. And here basically I will talk about something about this biochip architecture and how it is basically designed, or basically the different type of systems are developed, and very recent advances that has been done in worldwide research laboratories or industries. And I will be able to connect probably these two topics like biochemistry, which is part of biochemical laboratories, basically the topic of that, and then in between this computer engineering also, basically how this computer engineering is helping to connect this biochemistry to get this kind of biochip available in future in market probably. So so let us proceed. So my agenda of the talk is this: that I will first talk about that what is microfluidic biochip, or there is another name also that is called lab on a chip. So basically laboratory on a chip. So chip, you understand that that is a VLSI chip or like that. So it's a small device, and the laboratory means that biochemical laboratory, the pathological laboratory that we actually go for our blood test or something like that. So something like that biochemical laboratory. If we want to have it on this chip, so what it would be basically. So you have to control the fluids very very small amount in different way. So there are electronic control, there are means mechanical control, there are different type of control. So I'll talk about the basics of microfluidic biochip first uh, point, and the second point I'll go with this design of this kind of particular kind of microfluidic biochip, which is digital. So I think you all are from electronics, I guess, or maybe whatever the background. So basically it's an interdisciplinary topic, but in electronics I think you all know that there are two different domains. One is analog, another is digital. So I will talk about the digital microfluidic biochip domain. So where the digital microfluidics is the phenomena that will be means will be explained. And in this next, I will talk about something like some algorithm design, like which is basically protocol means algorithm. So the algorithm design for automated sample preparation, which is a special kind of requirement for any particular bioprotocol to be implemented on a biochip. So those that sample preparation involves two steps basically. One is dilution of a fluid, another may be the mixing of multiple fluids. Means when you have more than two fluids, then you call it as mixing. And when you have only one fluid as the sample and one buffer or the water to mix with it, and then we call this as a concentration to change. So that's why it's a dilution. So these two phenomena are altogether called as sample preparation. And then I will talk about this some challenges for new technologies and concluding. So yeah, yeah. So what is lab on a chip or the microfluidic biochip? So we have basically this complex operations in the pathological laboratory or the biochemical laboratory, which involves the pipettes or test tubes, small things, and many different sequence of steps, which are basically operations and which are complex, not very easy. So that's why we need skilled technician. So I cannot go to the biochemical laboratory and do that kind of test myself. I need some expert person to do that. So that's why the skilled technician is important. And another important thing is that bulky equipment. So there are a lot of big sized equipments which are very costly also are there inside the biochemical laboratories, which basically are used for this kind of biochemical operations or the protocols. This is a name that is used for this biochemical steps to be followed. That is called the bioprotocol basically. So bioprotocol or bioassay. So both are the same thing. So this terminology is used for that. So sequence of steps to be done, like in computer science or in electronics, we do the algorithm. So which is sequence of steps, programming steps. So like that, they also follow the sequence of steps in the biochemical laboratory. So those are called that sequence of steps is called the bioprotocol or bioassay. So when you have so many things involved in a biochemical laboratory, which are basically complex and skilled technician involvement and bulky equipments, then there is a requirement of huge money, huge time, or maybe huge cost into this. And also, you have manual intervention here in this system, so maybe there will be chance of error to happen. So that's why people started doing research on this topic to have a particular chip scale integration, which is called the lab on a chip. So laboratory, that chemical laboratory on a small chip. So this is not a very recent topic, but maybe around 20 years old, this topic. But still the research is going on because there are a lot of scope to do. Many different problems are there, challenges are there to achieve this. I think in the recent scenario, you all know about this test kit, that is RT-PCR test kit. So RT-PCR is a bioprotocol basically, which is followed for this.
புரியல
Yeah. So
கேட்கணும்
so RT-PCR is the protocol that is
கேட்கல
followed.
பவுன்ஸ் கீது இருக்கிறாரா புரியல
Hello.
மேம்
Is there any question?
ரெசிக்னேஷன் கொடுத்தாங்க
Excuse me. Hello. Hello. Is there anybody want to talk, or I can have the silence?
8 மாசம் ஆச்சு ஒன்றும் நடந்தது இந்த மாதிரி
Oh, I don't know what is. Hello. Oh my God.
சார்
Yes. Yeah. Somebody is speaking.
சார் tell me sir
Yeah. So somebody is speaking. So I do not understand, or I do not concentrate on my speech. So
no sir you can continue sir continue
okay. That's fine.
I think it is a cross talk you can continue
Okay. So what I was talking about, the RT-PCR, which is a bioprotocol basically, which is being followed by the biochemical laboratories to test about this COVID-19 virus. So that like that kind of protocols are, there are so many, means thousands and thousands of protocols which are followed for different diagnosis purpose. So So if we have a small kind of chips like as a handle device or a very small like a coin size, 1 rupee coin size device on which we can have the bio protocol to be executed, then it will be very easy for us, and there will be its cost will be very less because there will be a chance of doing this bulk production by the industry who will be interested to do this. So the problem is that if the system is manual, then there basically the time it is time consuming and laborious, and also it requires, I think I can take the pointer option here, that will be better. So it requires a considerable amount of sample and reagent, right? The fluid that is being used, it requires much more if it is manual process. If it is automated, then it can be very small size. It can be a disposable size, disposable chip, and also very small size, and which can be integrated and automated, and also it will be less expensive in that regard if it is very small. So the here actually one protocol has been shown. So it is showing just like some dummy operations or to just give you an idea that how these steps are looking like. So maybe some sample of some volume is taken in some pipette. You can consider it as a container, incubated
Sir,
for some duration with some temperature checking.
sir, sorry,
Yes,
sir. Voice is
yes.
slightly breaking, somewhat breaking, sir.
Oh,
If you want, you turn off your video because if
yeah,
any
yeah.
network issue, the videos will take more. If you want, you
Yes,
turn off your
yes.
videos. Then you can continue.
I should. Yes, yes. I should. Yes. I think is it better now? Is it better now? I have
Yes,
switched
yes,
off the
yes,
video.
yes, yes. Then you
The
continue, sir.
video is switched off, right? You cannot see me, right?
Yes, 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 yes.
Yeah, yeah, that's fine. Okay. So, so this is the bio protocol. So you can see that you take a sample and then you can take another reagent and do some operation, and then take the residual thing and then take another reagent and do some operation. So like this, there are several sequence of steps basically followed to finally determine something and give it as a result that this is the result of the test, or this is the result of the bioprotocol, of the bioassay. So this is the real life bioprotocol or bioassay as it look like. Next, I will talk about the two different kind of microfluidic biochips. So microfluidic, I think from the name you can understand now that fluid of microliter volume is being taken as the constituent of this fluid of this chip. So since it is operating for some biochemical operation, that's why it is called biochip. And the amount of fluid is in the scale of something like microliter or maybe sometimes nanoliter or sometimes picoliter also. So this is the name that suggests that it's very small size. And there are two different kinds of such microfluidic biochips, which is also known as lab on a chip. One is the continuous flow microfluidic biochip, another is digital microfluidic biochip. So continuous flow. So I think from the name you can understand that there is some. I think let me check. Let the pointer. Yeah. So this is a continuous flow microfluidic biochip that you can see here. There are channels. Green fluid is going through that bottom channel, and there are valves and pumps which actually distribute the fluid to different pumps which actually determine maybe input channel, input port to micro pumps. So this actually, if you assume that the yellow fluid is your buffer of that fluid has changed now after mixing. So this is the basic thing of a continuous flow microfluidic biochip, which has micro pumps and which has micro pulse based technology basically, and manipulates the fluids in micro channels. So these are the micro channels that you can see here, very small. And you have the DMF biochip, which is digital microfluidic biochip. So here you can see, I can just start the video. You can see. So here the fluids are basically reservoirs. So here you have 5 different squares. So which basically this is a macroscopic view. So you can imagine that it's a very small size chip, and these white color squares, big size squares, are called the reservoirs, and the small squares are basically the pathway basically through which the fluid droplet can move. So first task is to create the droplet like this. Here you can see the red droplet has been created, and this maybe the gray droplet and this orange droplet has been created. So you can imagine that how these fluids can be controlled through this electronic wire. So there are electronic wires. Each and every electrode can be controlled by applying voltages. And there is a basic physics behind this, why this droplet is created and why it is moving. So I will come to that in the next slide. So in this category of microfluidic biochip, where this digital microfluidic, which is called digital, why it is called digital? Because here the fluid is not a continuously moving. So here small size droplets are created. So that's why it is called digital. So each and every droplet, you can just imagine that this is this digitized, the digitization of the continuous signal. So that's why this is the name. So next, little bit detail of the digital microfluidic biochip.
Sorry, again, voice is breaking, sir. Participants, please wait. I think poor technical, there is a poor net connection in our expert side. Few seconds, we can wait. Sir will join again. Sir, sir, you have left the room, sir. I think network issue is there, sir. Actually, you have left the room. Now you have left the room. You're not in the live. Again, you need to join, sir. Yes, yes, yes. Automatically, it was left. That is why I called you, sir. Again, you. I myself is there, sir. Actually, myself is actually in live. I'm also coordinating with you, sir. Any issues, I can able to communicate with you, sir. Yes, sir. Again, you click the link and then you enter, sir.
Better means if I could open the thing on the application, but I am just looking at the slides and carrying on, so that's why I could not.
Fine. Okay,
Yeah.
okay. Now you have joined. Then I will start your screen share, sir.
Yes, yes. Screen share. Yeah, yeah. That's fine. Yeah. Is it now visible? Right? It's now visible. I think. Oh, okay, okay. Oh, a few seconds. Okay, okay. Yeah. Yeah, I have made it full screen. It's not coming. Right. Yes, yes. Is it now visible? But here in my screen, it is full screen. Okay. Visible? Okay, I understand. So it's coming. So there is some delay, maybe. Yeah, yeah. Okay. Yeah, yeah. So yeah, yeah. Yeah. Is it? Yeah. Oh, what is happening? I don't know. It's, so is it now clear? Okay. Oh, slides. Yeah. Stop. No, stop sharing it off there. I am not clicking there. Oh, again I have to do that. Okay. Maybe. No issue. This here. Now I have made slideshow mode. What it is? Coming? Okay. Maybe some delay is there, so I'm doing, but it is coming after some time. Oh.
Participants, a slight technical error. Please bear with us. Sir will continue now. Sir, can you hear my voice? Sir? Sir, hello? Sir, your voice is not audible, but you. Sir, can you hear my voice? Hello? Hello? Sir? Sudeep, sir? Is it audible, my voice? Sir? Sir, your voice is not audible. Voice is not audible. Participants, please kindly bear with us. I think in the expert side there is a technical issue. Sir is trying to reconnecting. Sir? Sir, your voice is not audible, sir. Yes, sir. Yes, sir. You should leave and then you can join it. Join again. Just you eject. Sir, can you hear my
Yes.
voice? Now it is
Yes.
audible,
Yes.
sir.
Okay. Now audible. Okay.
Yes, share your screen, sir.
Okay. Yes. Is it visible now?
Sir, it's coming, sir. Wait, we have to wait 2 minutes. There is a delay.
Is it visible now?
No, no, sir.
Visible now?
No, no,
Is it visible now? I'm
no,
audible
sir.
now?
No, sir.
No. Acha. Okay. Okay. So is it visible? No, not visible. Audible?
Audible, sir. But the screen
I
is
think there
not
is some
shared.
problem. Hello. No.
Sir, your voice is audible, but the screen is
Screen is
not
not sharing.
shared.
Okay, but it
Yes,
is showing shared.
we can wait for 2 minutes. Now share this, sir.
I understand. Okay, but
There is a delay.
now shared. Okay.
Yes, sir. Fine. You continue.
Okay. Okay. I shared.
Sir, voice is breaking, sir.
Earlier, but it is now shared. Yeah, that's fine. Okay, so I can continue
Continue.
right now from here.
Yes, sir. Continue, sir. Continue.
Yeah. So there is a this is the basically I am visible now. Okay. Oh, but yes, yes. Now this is on. Yeah. Okay. 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 Then okay. Share my screen. Okay. Yeah. Okay. It is perfect. Okay. That's fine. Okay. 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 Thank you very much. Okay. Thank you very much. Yeah. Yeah. Yes. So here, yeah. Yes, thank you. Yeah. So here I am going to explain that there are some basic operations on the droplets, which are basically this dispense of the droplet and the transportation of the droplet and mixing of the droplet and splitting of the droplet. So uh, I will go through different other slides and then come to those points that how those are being done. So here, basically, the detection and sensing module that is being explained. So I just, in the previous slide, I explained that there is a lead and photodiode arrangement, and the light goes through this droplet, and then the corresponding voltage is being measured here at the photodiode end, and from the calibration of the concentration to voltage plot, the actual concentration of the sugar or whatever the substituent in this droplet, that is being measured basically in terms of the percentage of concentration. And there is another arrangement that is for measuring the volume basically. So if you looked into this chip architecture, so you have two electrodes basically. One is this small electrode, which is basically square electrode, small, it is the side view, but on top view it will be square electrode. And the top electrode is a single electrode, which is a basically the big size electrode. Hello.
Sir,
Yeah.
sir, excuse me, sir.
Yes. Yes.
Sorry for the interruption. Again,
Yeah. Yeah.
we are unable to see your PPT.
Oh.
Sir, if possible, can you share the PPT so that we can load it from here?
Uh, it was little bit having some issues with some copyright issues, so I cannot share. I can share the talk, but I cannot share the slide. Yeah.
But we are unable to see your screen. Maybe you
I
are.
understand. Yeah.
Is
So I'm
there?
trying my best. Maybe
Yeah.
is it possible to schedule some other time this seminar? If
Yeah, sure. So let me check about it, sir. And just a minute,
yeah,
sir.
yeah, yeah, yeah.
PPT. Uh, Sir, yes, sir. We'll reschedule it, sir.
Okay, okay, that's fine because I will then arrange another internet connection, another place I will go and then do that.
Yeah,
So
sure,
that will
sir.
do.
Maybe
Yeah,
there may be some issue with your firewall settings or something.
yeah,
Not an
maybe.
issue, sir. We will reschedule it. We'll come back to you later on.
Yeah, 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 yeah.
Okay. Dear,
That's
dear
fine.
participants, for your kind attention, since we have some issue in sharing the screen, let us reschedule the session again and we'll get back to you. Sorry for the inconvenience made to you all.
Yeah, yeah, yeah. Thank you. Sorry for this inconvenience.